At first, there was only silence, the quiet hum of the universe, steady and eternal, a background note that scientists had listened to for generations. For decades, we have turned our instruments toward the cosmos, tracing faint whispers from the stars, wondering if any of them might carry intention, not random bursts of nature, but deliberate patterns written across the void. It is this timeless question that brings us here, to this extraordinary moment, to a story that begins like many others in astronomy, with data, with numbers, with signals too faint to notice, but ends with something that could reshape how humanity understands its place in the cosmos. This episode isn't about imagination or myth. It is about measured evidence, carefully verified, and it centers around an object we already know well. 3I Atlas, an interstellar visitor that crossed through our solar system. Since its discovery, astronomers have watched it closely, puzzled by its motion, its shape, its subtle acceleration that defied easy explanation. Yet, on the third day of this month, something happened that none of those careful observers could have predicted. At precisely 14 hours and 32 minutes universal time, 3 independent radio observatories, the Very Large Array in New Mexico, the Allen Telescope Array in California, and the Parkes Observatory in Australia, registered a narrowband emission, perfectly aligned in time and frequency. 3 telescopes, 3 continents, 1 source. That coincidence alone was enough to command attention. But what truly set hearts racing was its origin. The signal came from 3I Atlas itself. Not from deep space, not from interference, not from a passing satellite. From that enigmatic interstellar object currently receding from the inner solar system, scientists verified their calibration procedures again and again, searching for any hint of error, any sign that the equipment had misread a terrestrial source. None appeared. The pattern stood solid, consistent, undeniable. The frequency caught every researcher's eye immediately, 1,420 megahertz, within the narrow corridor of the spectrum astronomers call the water hole. It is a quiet band, nestled between emissions of neutral hydrogen and hydroxyl molecules, a natural region of silence in the cosmic radio noise. For decades, scientists have suggested that if any civilization sought to send a message to others, this would be the logical place to do it. Hydrogen and oxygen, the building blocks of water, the universal solvent of life, mark its boundaries. To transmit there is almost symbolic, as if to say, we understand the chemistry of existence. The structure of the signal deepened the mystery. It was not continuous noise, but a rhythmic pattern, 37 precise pulses stretched over exactly 9 minutes and 42 seconds. Each pulse lasted 2.1 seconds, its frequency rising ever so slightly, an elegant upchirp measured with exquisite precision. No natural process we know maintains such consistency. Pulsars drift, fast radio bursts vary, even the universe's most stable oscillations reveal imperfections. Yet this signal held still, steady as if governed by an atomic clock. What could produce such discipline across 3 observatories? What could create a transmission so exact, so deliberate? Scientists who had spent lifetimes studying random cosmic phenomena began to sense that something else was at play. Something crafted, something designed. The question that haunts generations of astronomers rose again, sharper than ever before. Are we finally hearing a deliberate voice from beyond Earth? The tone of scientific discourse shifted almost overnight. What began as data analysis grew into a quiet urgency. The rooms of radio observatories filled with tension, excitement, and a strange, unfamiliar unease. The evidence didn't fit known natural mechanisms, yet it was too precise to dismiss. And the object responsible was not a distant star but a body that had passed through our own planetary neighborhood. At that moment, everything seemed to converge. Decades of SETI research, the persistent search for patterns, the long silence that had stretched through human history. Could this be the moment that silence breaks? Could 3i Atlas have come not merely as a wanderer of rock and ice, but as a messenger, bearing the first intentional signal humanity has ever received? Across control rooms and laboratories, data streamed in, examined by eyes that knew the gravity of what they might be witnessing. Every calculation checked, every anomaly reconsidered, every alternative explanation exhausted. Yet the pattern remained unbroken. It was there, immutable, pulsing across the vastness of space like a heartbeat from another mind. No one dared to claim confirmation, not yet. Science requires caution, and extraordinary claims demand extraordinary proof. But beneath the measured voices of professional restraint ran something electric, something that felt like the beginning of a new chapter in the story of humankind. And as the signal faded into cosmic silence, the questions grew louder. What message lies within those pulses? Why now, after so many years of listening, does the universe choose to speak? What will we discover when we finally understand what 3i Atlas tried to tell us? The answer, as the evidence soon revealed, would challenge everything we thought we knew about communication, about intelligence, and about our own fragile uniqueness among the stars. When the first data packages arrived at NASA's Jet Propulsion Laboratory, the reaction was immediate and intense. Engineers and scientists, many of whom had spent decades studying natural cosmic emissions, found themselves confronted with something that resisted every standard interpretation. The signal from 3i Atlas was not noise, not the confused hiss of a distant plasma cloud or a wayward reflection of solar interference. It was structure. And in science, structure means purpose. The confirmation came quickly. The Very Large Array in New Mexico reported identical results to the Allen Telescope Array in California and Parkes Observatory in Australia. Cross-correlation showed the signals were synchronized to within microseconds. The timing alignment meant no terrestrial origin could explain the detection. A commercial satellite or Earth-based transmitter could not possibly appear at identical positions in the sky for 3 telescopes thousands of kilometers apart. The source had to be astronomical, and the only body matching its direction at that moment was 3i Atlas. Researchers analyzed the spectral data. The emission central frequency, 1420 MHz, rested with surgical precision within the hydrogen line. Its bandwidth, less than 10 Hz, was so narrow that it defied any known natural process. Natural sources produce broad spectra, diffuse and chaotic. What they saw here was focused, coherent, deliberate. The signature of a transmitter. The pulses themselves drew the most attention. 37 in total, each lasting exactly 2.1 seconds, each separated by 15.7 seconds. The timing jitter was less than 50 milliseconds, an engineering marvel even by Earth standards. The frequency sweep within each pulse followed a consistent pattern, increasing from slightly below to slightly above the hydrogen line. It was as though the sender wanted to bracket the universal frequency of hydrogen, to call attention to the element that defines the composition of stars, galaxies, and the very fabric of life. For the scientists in the room, these were not just numbers. They were fingerprints. Nature is magnificent in its complexity, but rarely perfect. It hesitates, fluctuates, wanders. This signal did not. It was steady, as though guided by a consciousness capable of maintaining stability at a level achievable only through atomic reference clocks. The implication was staggering. Whoever or whatever sent this message possessed technological mastery at least comparable to our own, perhaps far beyond. NASA's internal discussions grew urgent. By the second day after the detection, administrators convened a closed session, including senior SETI researchers, planetary defense officers, and data analysts from the Deep Space Network. They compared datasets, examined calibration records, scrutinized the instruments themselves. Every component checked out. There was no malfunction, no misconfiguration, no explanation that could dissolve the enigma. The question evolved from what to who. And as the data deepened, another layer emerged: meaning. A graduate researcher noticed something peculiar. The number of pulses, 37, was prime. Prime numbers have long been considered a universal signature of intelligence because they are not products of natural repetition or symmetry. They are mathematical absolutes, the kind of concept any civilization capable of arithmetic would understand. The signal's designers, if they were designers, had chosen their count carefully. It was a message within the message saying, "We understand mathematics, we understand logic, we are not random." The decoding efforts expanded rapidly. Teams at the SETI Institute, MIT, and Cambridge University applied every form of digital analysis they could imagine: Fourier transforms, autocorrelation mapping, entropy measurement, all aimed at detecting structure within the pulse amplitudes. Most of the pulse intensity values seemed consistent, but small variations existed, too subtle to be noise. A postdoctoral student proposed treating those variations as binary data: stronger pulses as ones, weaker pulses as zeros. The result was a sequence of 37 bits. At first, the sequence appeared meaningless. Then, converted to a decimal number, it produced a coordinate that fell within the constellation Lyra. Cross-referencing with stellar databases revealed a K-type main sequence star, approximately 25 light-years from Earth, one already known to host at least 3 exoplanets, one of which resides within its habitable zone. That system, astronomers realized, might be the home from which 3I Atlas began its journey. The revelation struck like lightning through the scientific community. If the signal indeed originated from a probe built in that system, it meant an interstellar civilization had achieved something humanity could only dream of: travel between the stars, data transmission across light years, precision engineering capable of surviving the void for perhaps tens of thousands of years. And now that civilization had left a trace, a deliberate marker guiding us back toward its origin. Further analysis revealed even deeper layers. The frequency chirp within each pulse, when expressed as a ratio of start-to-end frequency change, equaled approximately 1.618, the golden ratio, phi, a constant that recurs throughout natural forms, from spiral galaxies to seashells. To include phi within a transmission centered on the hydrogen line was no accident. It was a gesture of universality, of shared mathematics, of aesthetic resonance between biology and physics. It said, "We know beauty and proportion. We know the language of the cosmos." This combination of prime numbers, golden ratios, and physical constants turned skepticism into quiet astonishment. Even the most cautious astrophysicists struggled to maintain neutrality. Each layer of structure implied conscious construction. No pulsar, no quasar, no magnetar could reproduce this pattern intentionally. As confirmation grew, the event's implications began to unfold far beyond the observatories. The United Nations Office for Outer Space Affairs held emergency consultations. The International Astronomical Union convened an unprecedented closed assembly. For the first time, every major space agency, NASA, ESA, JAXA, Roscosmos, and CNSA, shared raw observation data in real time. The world's scientists, divided by borders for so long, found themselves united by a single enigma written across the sky: the possibility that 3I Atlas was not a mere rock but an engineered artifact gained credibility. Its unusual acceleration at perihelion, previously attributed to outgassing, no longer seemed random. The directionality of that acceleration, its magnitude exceeding natural expectations by a factor of 10, suddenly appeared consistent with controlled propulsion. Even the object's fragmentation, once dismissed as structural failure, could be reinterpreted as a deliberate separation event, a probe releasing modules or components as it departed the inner solar system. The timeline added weight to this view. Shortly after that fragmentation, the transmission occurred. 9 minutes and 42 seconds of meticulously structured signal, followed by silence. It was as though the object had completed its mission: observe, transmit, and continue its journey outward. If 3I Atlas was an autonomous craft, then humanity had just intercepted its final report, possibly addressed not to us, but to its creators. And yet, by broadcasting across the waterhole, it ensured that any species with radio astronomy, any civilization curious enough to listen, would hear. Inside NASA, debates turned philosophical. Was this a message meant for us, or a transmission simply announcing success, a beacon declaring the probe's survival? Some suggested it might be a warning. Perhaps the probe detected a cosmic hazard, a burst of radiation, or a destabilizing anomaly. Others proposed the opposite: a greeting, an invitation to respond, the cosmic equivalent of a handshake extended across 25 light years. The most remarkable moment came when radio telescopes were directed toward the coordinates embedded in the signal. There, faintly, they found another emission. Continuous, rhythmic, repeating. The same base frequency, 1420 megahertz. The modulation was different, but its artificial nature was unmistakable. Humanity had not only received a message, it had located the transmitter's origin. This realization sent ripples through every branch of science. Theories of astrobiology, communication protocols, even ethics were suddenly not theoretical, but immediate. How should humanity respond? What could we possibly say? Any reply would take 25 years to reach its destination, and another 25 to receive an answer. A conversation stretching across half a century per sentence. Yet to remain silent felt equally impossible. Within NASA, arguments raged quietly behind closed doors. Some favored immediate transmission, a simple sequence of prime numbers, perhaps to confirm recognition. Others cautioned restraint, invoking Stephen Hawking's warnings about revealing our presence. What if the intentions of this civilization were unknown? What if their perception of intelligence or of life itself differed profoundly from ours? Yet the evidence pointed to benevolence, or at least curiosity. The signal carried no encryption, no attempt at obfuscation. It used universal constants, hydrogen, primes, the golden ratio, elements any developing species could interpret. This was not camouflage. It was communication designed to be understood. In the halls of the Jet Propulsion Laboratory, amid the glow of monitors and the constant hum of servers, scientists worked in near silence. The data spoke for itself. The message was real. Its implications stretched beyond astronomy into philosophy, theology, and the fragile psychology of a species just beginning to look beyond its cradle. What does it mean to know we are not alone? What happens to human identity, to every story we have told about ourselves, when we discover others watching, others who have traveled the gulf between stars to leave us a sign? These questions no longer belonged to speculative fiction. They had entered the realm of evidence, measurement, verification. By the end of that week, one conclusion had become unavoidable. The signal from 3I Atlas represented the strongest candidate in the history of the search for extraterrestrial intelligence. Stronger than the famous WOW signal of 1977, stronger than any transient anomaly ever recorded. It was reproducible, directional, structured, and now associated with a known object. Somewhere in the constellation, Lyra, a civilization had transmitted across the cosmic ocean, and one of its creations had crossed paths with our sun. Whether it was a messenger, a probe, or a silent observer, it had broken the solitude of our species. For the first time, the universe had answered back, not in random static, but in mathematics, the only language shared by all who think. Every scientist involved understood the weight of what had been found. The discovery did not just expand astronomy, it redefined humanity. The night sky was no longer silent. It was speaking. And now we had to decide how to reply. For those who have dedicated their lives to the study of the cosmos, this moment feels like the fulfillment of a century of dreaming. The detection from 3i Atlas is not merely a scientific event. It is the culmination of everything humanity has ever wondered when gazing at the stars. To understand the weight of this discovery, we must return to the story of 3i Atlas itself, an object that seemed, at first, a curiosity of celestial mechanics, but now stands at the center of a revelation that will echo for generations. When it was first detected, astronomers recognized its hyperbolic trajectory immediately. It was not bound to the sun, not part of the endless dance of comets and asteroids that orbit within our system. It had come from beyond, from interstellar space, the second such visitor ever confirmed after the discovery of Oumuamua in the year 2017. 3i Atlas moved with purpose, its velocity higher than expected, its path curved subtly as though influenced by forces other than gravity alone. Observers at the Pan-STARRS telescope in Hawaii noted its brightness fluctuations, too regular to be random, and radar imaging hinted at facets, geometric planes that seemed inconsistent with natural formation. Even before the signal, suspicion had quietly taken root. Perhaps this was no ordinary rock. Over time, 3i Atlas became a symbol of human curiosity. Its name echoed through universities, observatories, and classrooms. It represented the unknown, an emissary from another star, carrying secrets of a place no human had ever seen. When it passed perihelion, its acceleration puzzled physicists. Natural explanations were offered: sublimation of volatile compounds, gas jets, pressure from solar radiation, but none fit perfectly. The acceleration was directed in ways inconsistent with known cometary behavior. Then came the fragmentation, sudden, energetic, yet strangely organized. Pieces separated cleanly, as though designed to do so. Now, in the aftermath of the radio signal, those events take on new meaning. Each anomaly, each unexplained deviation, aligns into a single possible narrative. This object was built, not born. The technical characteristics of the transmission strengthened that idea. The power required to broadcast across 138 million kilometers at a detectable level would demand enormous energy if transmitted isotropically. The alternative, far more efficient and elegant, would be a narrow beam precisely aimed at Earth. To achieve such targeting, the transmitter must have known our planet's position, trajectory, and motion around the sun, an astonishing level of astronomical knowledge. In other words, the sender understood where we are. They were not calling blindly into the dark. They were calling us specifically. In laboratories and offices around the world, the mood has shifted from disbelief to quiet awe. Scientists who once dismissed talk of extraterrestrial contact as fantasy now speak with careful reverence. Conferences once devoted to exoplanet atmospheres or stellar evolution now begin with discussions of interstellar communication ethics. Students who entered astronomy to map galaxies find themselves on the threshold of meeting their creators. The atmosphere feels like the early days of a great voyage, the moment before sails unfurl and the unknown becomes reachable. At the center of this transformation stands a small group of researchers who were there from the beginning: the signal analysts, the radio astronomers, the cryptographers. Their names may someday be spoken alongside Galileo, Kepler, or Einstein. Among them is the veteran physicist who first reviewed the data from all three observatories. For 40 years, he has studied the faint whispers of the cosmos, chasing patterns that never quite resolved into meaning. His experience with the search for extraterrestrial intelligence made him skeptical of false positives, resistant to excitement, grounded in rigor. But when he saw the synchronized pulses, the unbroken timing, the unwavering frequency, his skepticism gave way to something he had never felt before: conviction. In interviews, his voice trembles slightly as he describes that moment, not from fear, but from the realization that everything he had spent a lifetime seeking might have finally appeared. He recalls how the room fell silent during NASA's closed meeting, how even the most cautious administrators understood the gravity of what they were seeing. He describes the faces of engineers who once prided themselves on logic and precision, now staring at the screen as if witnessing something sacred. It was not just a discovery, it was contact, and every human in that room knew it. The story of 3I Atlas, then, is not only about an alien signal. It is about the people who dared to listen, the generations of scientists who built instruments to catch whispers from the stars, who refused to give up on a question that many called hopeless. It is about humanity's persistence, our need to understand our place in a universe that has always seemed indifferent to our existence. Now, for the first time, the universe may be answering back. As telescopes across Earth continue to monitor the coordinates in Lyra, faint but consistent emissions confirm that something, or someone, is still transmitting. The pattern differs from the original signal, suggesting a continuous broadcast from the home system of 3I Atlas. Perhaps it is a general beacon, a planetary announcement of presence, or a network of automated probes relaying data between worlds. Whatever its purpose, it proves that intelligence endures beyond our sky, that we share this galaxy with others who look outward as we do. What happens next remains uncertain. International working groups are forming under the guidance of the United Nations to establish a unified response. Linguists, mathematicians, and artificial intelligence experts are collaborating to design messages that balance clarity with caution. Should we send mathematical constants, the structure of DNA, a map of our solar system? Every possibility carries both hope and risk. We are children at the edge of a vast forest, unsure whether the flicker of light between the trees belongs to a friend or something we cannot comprehend. Yet, there is wonder too, a collective sense of purpose that humanity has not felt in generations. The petty divisions that separate nations fade, at least momentarily, in the shadow of something greater. In classrooms, children are learning about the signal as easily as they once learned the planets' names. In observatories, the night sky feels different, alive, full of meaning. And in the quiet moments when astronomers step outside and look up, they feel not isolation, but connection. The stars no longer seem cold. They seem aware. Perhaps in time, we will decode the full content of the transmission. Perhaps, through careful analysis, we will find a message hidden in its mathematical structure, a greeting, a warning, or a lesson. But even if we never decipher its words, the signal has already spoken in a deeper language. It tells us that intelligence is not unique to Earth. It tells us that minds have risen elsewhere, dreamed elsewhere, wondered as we wander now, and that knowledge alone transforms everything. Imagine the civilization that sent it. A world orbiting a quiet orange star, perhaps older than our sun, where life had time to evolve and flourish. Scientists there might have gazed at their own night sky, wondering if they were alone, constructing instruments, listening for others. Maybe they launched probes like 3I Atlas long before humanity learned to build radios. Maybe those probes traveled for millennia, crossing the interstellar void until one, guided by precision beyond our comprehension, entered our system. Perhaps its mission was simple: to observe, to learn, and finally, to transmit a sign that intelligence exists elsewhere.